Hello and welcome to our latest AEC TechTV show. I'm Aarni Heiskanen, a construction innovation agent based in Helsinki, Finland.
And hello from me, I'm Paul Wilkinson. I'm a technology consultant, a blogger, writer and freelance journalist, and I'm based in London.
AEC TechTV is our weekly video news magazine show looking at the latest technologies used in today's architecture, engineering and construction industries.
And coming up in today's show, I review a report on data standards for the real estate sector. Aarni has been one of the judges on the Tekla Global BIM Awards. Heiskanen talks about timber construction and the Metsä Pavilion in Tokyo. Professor Olli Seppänen talks about situational awareness in construction. I take a look at some of the news for the SME, the small business end of the construction industry, and we look forward to some future events.
We are now including more news items in our show. Let's hear from Paul about some of his chosen news stories.
To help us find the right information at the right time and in the right format, we need data standards. A recent report from the UK's RED Foundation explores the role of standards in the flow of data across real estate, a good many that are also internationally used. The RED Foundation was set up to ensure that the real estate sector benefits from an increased use of data, avoids some of the risks that this presents, and is better placed to serve society. The foundation, established by a number of real estate organisations, has published a report entitled The Role of Standards in Enabling a Data-Driven UK Real Estate Market. It was produced by Dan Hughes of Alpha Property Insight. And in the report, he argues that in an increasingly digital and data-driven world, how the built environment adapts is going to be key to its success. The sector is seeing exponential growth in the data that's available and greater emphasis on the outcomes and on life cycle views of decisions. The paper looks at what is available, what is needed, and what people may need to do. Hughes has undertaken a high-level review of what standards are available in the market and which have influence over the creation, management or use of data. It provides a visualization of the many well-established standards and highlights that they often tend to be focused on either a specific stage of the building cycle or a specific job function. As data is increasingly needed to inform decisions beyond those building stages or job functions, standards need to be used to facilitate data increasingly being more widely used. The report also identifies that awareness of all the standards available in the market is not high beyond the sectors to which they were originally applied. And this can mean that adoption and wider use of standards is limited and lead to some overlapping or similar standards being created in isolation. The 6 headlines in the report are summarised. Number 1, real estate has a well-established and robust set of standards. As well as the report, the RED Foundation has published a spreadsheet free to download showing all of the standards that they've reviewed. Number 2, we have an increased quality of data available in the sector. Third, data must be able to flow freely and standards have a key role to play in this. Fourth, existing standards need to be more valued and more easily discoverable. 5, the value and cost of standards and data needs to be recognised fairly, and professionals will have to deal with increased complexity regarding the data they use and the standards that influence this data. The report recommends future steps in 4 areas: improving discoverability, increasing connectivity, heightening awareness of the value of the standards across the real estate sector, and the role of people. As the volume and variety of data used increases, who is responsible for ensuring that standards are applied correctly definitely needs to be considered. Aarni has been one of the judges on the Tekla Global BIM Awards. Heiskanen talks about timber construction and the Metsä Pavilion in Tokyo. Professor Olli Seppänen talks about situational awareness in construction. I take a look at some of the news for the SME, the small business end of the construction industry, and we look forward to some future events.
Trimble announced on the 1st of October the winners of its Tekla Global Building Information Modeling Awards, a biennial competition showcasing the world's most impressive structural construction projects that use Tekla solutions. Over 135 projects were entered in this year's competition, which included winners of Tekla Regional BIM Awards from 36 countries. Tekla Global BIM Awards started in 1999, welcoming projects that exhibit innovation and push the boundaries of structural engineering and BIM. And this year, I was invited to the selection committee, and together with Andres Carlén, Burku Akinci and Michael Evans, we chose this year's global winners. The best BIM project and the best infrastructure project is Randselva Bridge in Norway by Sweco Structural Engineering, PNC, Armando Rito and Isaksen. The Randselva Bridge is the first bridge of its size to be constructed using a drawing-free, model-based process. The project relied on a parametric 3D model as the only official documentation and source for information needed to build the bridge without drawings. Tekla Structures software helped engineers to overcome challenges related to the bridge's complex, slender geometry and heavy reinforcement, while clash detection ensured the design was constructable. Sweco's team in Norway, Finland, Denmark and Poland used Tekla model sharing to work on the same model on a daily basis. In addition, Trimble Connect collaboration platform enabled communication and quick resolution of issues. In the field, workers used Trimble Sight Vision system, an outdoor augmented reality solution, to place and view the 3D model at a true-to-life scale. Randselva Bridge was also the winner of the Best Infrastructure Project category. The award for the Best Commercial Project went to 19 Elms from the UK by Solved Structural Design. 19 Elms is a mixed-use development on the south bank of the River Thames with a total project value of approximately €328 million. BIM was especially useful in detailing one of the core base rafts located 2 stories below ground, requiring all plant and materials to be supplied through small manholes and constructed in tight conditions. Throughout the project, the 3D model served as a single source of truth, and the model immediately highlighted areas of heavy congestion and severe rebar clashes that would have caused costly delays. The best industrial project is Bluminmäki Wastewater Treatment Plant in Helsinki by Helsinki Region Environmental Services Authority, YIT, AFRI Finland, FCG Finnish Consulting Group and A-Insinöörit. The ability to collaborate and share information across disciplines and stakeholders with Trimble Connect was critical for the success of this massive project. The best public project is University Hospital's Bridge Hospital in Helsinki, Finland, by A-Insinöörit, HUS Kiinteistöt, SRV, Team Integrated, Peikko Finland and Granlund and Ramboll. Throughout the design process, 3D models played an important role in collaboration, helping stakeholders visualize the design and coordinating a vast number of disciplines and subcontractors. The best sports and recreation project is Saga Natatorium for the Tokyo 2020 Olympics in Japan by Yantai Daiso Design. A team of 5 people completed the structural steel model in 10 months. They used Tekla Structures auto-connect functionality to create connections to the nodes in the model. The best small project is a transmission tower in the form of a lion and an eagle, a symbol of a town in Russia. It was designed by Bell Energomash BZEM. The tower's steel profiles were cut and punched and drilled using CNC data directly from the Tekla Structures model. The award for the best student project went to an Indonesian team from Universitas Lampung Mangkurat. The project was the Kalimantan New Mosque for 16,000 worshippers. A combination of steel and concrete, the mosque was designed and modeled with Trimble's SketchUp and Tekla Structures. The students also used the integrated visualizer tool in Tekla Structures for the structural 3D rendering. The best developer project winner is JMT Consultants from the USA with their Bolt Clearance Check, a Tekla structures application checking if there's enough space to assemble bolts. It is notable that the application was developed in just 15 hours. Finally, the special recognition went to Twickenham Riverside Development Bid in the UK by Mason Navarro Pledge. This project proposal was intended to revitalise a section of the Thames Riverside and drive economic improvement to the wider Twickenham area. The project demonstrated imaginative and innovative use of Tekla Structural Designer for a wood and concrete design of complex geometry. You can read more about the winners on my blog at aec-business.com.
That was Aarni there, talking about the Tekla BIM Awards for 2020. The Metsä Pavilion opened its doors on 6th of October in Tokyo. Aarni has taken a look at the project that showcases timber construction.
The Metsä Pavilion was officially opened on the 6th of October 2020 on the grounds of the Finnish Embassy in Tokyo. It is a Business Finland's project in collaboration with Metsä Group. The Metsä Pavilion showcases how to construct a stylish building quickly and efficiently by using standard wooden components. They were made from Kerto LVL, laminated veneered lumber. The pavilion was designed by renowned Finnish architectural office Helin & Co. Architects. The prefabricated parts of the building were manufactured in Finland by Timber Point and shipped to Japan. The construction on the location took just 10 days. The pavilion is designed to be disassembled and assembled again at a new location. During the Summer Olympics and Paralympics, the Metsä Pavilion will serve as a home base for the Finnish national teams. It will stay open until the end of 2021, hosting various events organized by Finnish companies and organizations. Here's architect Pekka Helin talking about the design.
Tämän lähtökohtahan oli se, että ei tehdä mitään hyvin sellaista erikoista ja muodoltaan ainutkertaista, vaan esitellään teollisen tuotteen hyödyllistä käyttöä, jolloin tämä sisältää aika yksinkertaisia kappaleita. Nämä kantavat pystyrakenteet on tehty tällaista esivalmisteisista kaksoispilarilevyistä, kertopuuta. Puu näkyy vertikaalirakenteissa, seinäpinnoissa, alakatoissa. Et hyvin monikäyttöistä joustavaa tilaa, josta avautuu sitten tähän lähetystön puutarhaan näkymä.
And here Lasse Hietanen of A-Ins Group talks about the engineering of the pavilion.
Ei rakennesuunnittelu mielessä ole pelkästään yhtä kiinnostavaa kohtaa, vaan se on kokonaisuutena hyvin kiinnostavaa. Se on haastanut näiden jääkysjärjestelmätyypin ja teollisen tehokkuuden kautta niin rakennesuunnittelija tekemään sitä kokonaisuudesta yhtenäisen paketin. Ja toki on sijoitettuna niin maanjäristys ja sitä kautta tuulikuorma on poikkeuksellisen korkea, että on ollut huomioitava tässä kokonaistabiliteetissa, että miten rakennus saadaan pysymään pystyssä. Metsä Pavilionin suunnittelussa on huomioitu tämä teollinen tehokkuus, eli on lähdetty siitä, että optimoidaan materiaalihukkaa mahdollisimman pieneksi. Palkit ja pilarit on paljon samasta paksuudesta ja samasta leveydestä pyritty käyttämään niin tehokkaasti samaa tuotetta, jotta ei tarvitse tuottaa linjalla montaa eri paksuutta ja montaa eri kappaletta kokoon. Esivalmisteisuus oikeastaan siirtää sen työn suunnittelupöydälle ennen kuin se työmaalla aletaan tuottamaan, eli se tuo hyötyinä sitten sen työmaalle, että se aikataulu pitää ja mitä yllätyksiä tulee vähemmän sen työmaan valmistamisen aikana. Puustosuunnittelu vaatii semmoista erityistä yksityiskohtien paneutumista. Se on vähän erilainen kuin teräs ja betoni, että pitää pienet yksityiskohdat huomioida ja liitoksissa erityisesti on semmoista haastetta. Tarvitaan sitä geometria analysointia, mihin mahtuu mitäkin liittyy. Kertoäänevällä ominaisuutta oikeastaan sieltä puutuotteiden yläpäästä, eli siellä on varsinkin palkkirakenteissa pilariliitoksessa pystytään optimoimaan tukipaineita ja poikittaista puristuskestävyyttä hyvin ja pystytään tekemään pienempiä tukipintoja ja muita tämmöisiä optimointeja.
The designs for all the components used in the pavilion are freely available on Metsä Wood's open source wood platform. To learn more, go to metsäwood.com/talkingwood. That was Pekka Helin and Lasse Hietanen describing the Metsä Pavilion in Tokyo. Next, Professor Olli Seppänen talked at the recent WDBE event about situational awareness in construction.
Today we are going to hear about situational awareness. I will first describe what are the gaps and what is the current status. Then we will hear about what are the obstacles of implementing situational awareness, what is the role of ontology in making this work, and then we have a case study of 4 companies integrating their solutions using the ontology developed in this Dixon project. First of all, what is situational awareness? We define it in this way. We have some kind of plans and change tracking, and earlier digitalization has focused mostly on the blue side. Then we have the actual situation in project environment, the green area. Traditionally, people have been making perceptions and observations manually based on this actual situation. For example, by taking notes about what is going on site. These perceptions have been stored in human memory and socially distributed in meetings. Now with technology, we are getting new alternatives how to get situational awareness, and we call it digital situational awareness. We have sensors, we have cameras, we have all kinds of technologies that can be integrated, and situational data can be collected automatically. And this can all be saved to computer memory and automatically distributed. So now we have developed technology, there are sensors, there are positioning beacons, machine vision. We have simplified process. Big companies are implementing prefabrication and tagged production, and digital engineers are collecting digital data. But whenever we measure situation picture, we don't see that pretty results. For example, here you can see that when we measure how much the workers are in work locations, they spend 52% of their time in work locations altogether. But if you measure the time they spend in work location without interruptions, and they have to be present for 10 minutes in the work location without going away, we get down to 34%. So only 34% of the time people are able to work without interruption in construction sites. When we look at whether they are in the correct location assumed in the plan, we get around 50% of the time. So out of this 34%, 50% of the time is where the plan is assuming the people would be. So we get a track record of 17%. We have defined a couple of KPIs based on this uninterrupted presence. The first one is presence index, which is uninterrupted presence in a task divided by actual duration of the task. Out of all of our measurements, we get 34.5% average with large variation. And variability, of course, is the root of all evil. When we measure the presence to plan ratio, so how much uninterrupted presence you need compared to what you planned, we get 33.8%, which means that there's an opportunity of 60% in compressed durations if we can reduce interruptions. Only 1/3 of the duration is needed to actually do the work. This basically means that we need to get rid of external variability. It's not enough to digitalize the construction site, but we need to figure out also all the other supporting flows connected to the construction site. So based on uninterrupted presence, we are basically measuring how much of the time the worker is present in the work location. So we are measuring optimal productivity, work method, skill differences, standardization. These are in the 35%. That's the only thing that is within the scope of control of the worker and the subcontractor in question. The remaining 65 to 70% is due to external factors. And the solutions we are going to present today are related to measuring and improving the external variability, which is where we should start because it explains 70% of the workers' productivity. And next we go to the actual solutions.
That was Professor Olli Seppänen. I've been looking at some of the technologies that are deployed by small and medium-sized businesses, the types of companies that make up the majority of the construction sector in most developed economies. Industry coverage about digital transformation often focuses on the processes and tools available to larger businesses in the construction sector. But digital working is something that can be embraced by every business, and including small and medium-sized businesses and even micro businesses, of which there are literally thousands in the construction sector in just about every developed economy. The costs of technology have reduced. Broadband connectivity and cloud connectivity are now increasingly widespread. We're increasingly mobile. We have tablets and smartphones putting powerful computers literally in the pockets of many site workers. And software vendors are also developing solutions expressly meeting the needs of smaller businesses. Let's look at a few examples. I recently talked to a Norwegian company called Fon. Fon Construction was founded in 2016 by Jan Tore Grindheim after he had first-hand experience of poor communications, lack of documentation and inefficiency when he commissioned his own house. Looking to improve collaboration and information sharing among the various subcontractors involved, he created Fon Construction. From the start of its development, the Fon application focus has been on what does the site worker actually need to get his job right. The business was launched commercially in 2018 and aims to provide site workers with an intuitive and easy to use solution that could be accessed via the web and in mobile and on mobile devices. It aims to provide site workers with an intuitive and easy to use solution that can be accessed via the web and on mobile devices, both iOS and Android. It puts the latest information literally at the fingertips of site-based personnel while providing a hub for managing communications. In less than 2 years, Fon Construction has signed up over 50% of major home builders in Norway. And in September 2020, it announced a $3 million funding round led by an Oslo-based venture capital firm. It's declared its aim to reinvent project management for construction globally, and the company now has sales teams looking to grow the business in the United Kingdom and in the United States, where Fon says around 85% of US home builders are not using any project management software. And we hope to get Fon to talk on a future edition of AEC TechTV. Other businesses are also targeting the home and small builder market. On Extranet Evolution, I've looked at 2 businesses that look to make it easier for tradespeople to source materials from builders' merchants. In May 2019, an online marketplace, Snaffle, was launched. It aimed to make it easier for SME builders to buy tools and materials while creating extra online sales for traditional suppliers in the industry. And earlier this year, BuildIT launched its mobile-based materials ordering service and allowing users to check merchant stock availability. Initially launched in the London area, BuildIT Direct aimed to deliver from a list of over 20,000 items held on the app. Tradespeople can select from either the 90-minute or the same-day delivery option. Many orders are under 12 kilos in weight and so fit on a motorbike or in a small van. For larger items that might need to be hired, another service was recently launched. Scrap raised £1.2 million in seed funding as it set out to transform how everything is hired in the construction industry. It claims a reputation as a skip hire disruptor and plans to innovate in other parts of the industry, including concrete, portable toilets and machinery, putting these on demand via an Apple or Android mobile app. Scrap has been trialled with hundreds of suppliers across London, Manchester and Birmingham, completing over 10,000 deliveries to thousands of construction companies, large and small. It aims to automate entire construction hire supply chains across major cities globally over the coming years. Some small businesses are also looking to develop their own solutions After I discovered Scrap, I learned about a skip hire business in Stoke-on-Trent in the English Midlands who had worked with a marketing services agency, AdTrack, to develop their own skip hire service. If you are providing solutions to the SME market, please let us know. Or if you are the user of an application that you really like, please also contact us and we'll give you a chance to say why you like that solution. In our final news section, Aarni looks forward to some upcoming events.
The Lean Construction Institute's virtual LCI Congress 2020 takes place from October 19th to October 23rd. Visit www.lcicongress.org/2020 to learn more. BuildIT, the Middle East region's largest virtual construction event, will take place on the 26th to 28th of October. Use the link aectech.news/BuildIT to register for free. See you there.
Thanks, Aarni, and thanks also to our contributors, to Olli Seppänen and Lasse Heiskanen, and thanks also to you for watching.
AEC TechTV is a weekly show. Our next show is already in development, but we want your ideas and suggestions and, better still, your contributions for future shows.
Yes, please visit our website, email us, follow us on Twitter, or subscribe to our YouTube channel, and many thanks to the over 100 people who've done so far. And thanks for watching. Goodbye.
And goodbye from me.